We find the end behavior of a function by finding the limits as x approaches positive or negative infinity. So as x approaches positive or negative infinity, that just means find the end behavior of a function. So here we want the limit as x approaches negative infinity of this polynomial function. So if I'm looking at a polynomial function, I look at the leading term and I see that it is positive and even. So that means it's going to have the same end behavior as positive x squared. So as x approaches negative infinity, that limit is approaching positive infinity. Once again, in part B, we are approaching positive infinity of another polynomial function. So I'm going to look at the leading term, which has the highest degree, and it is negative and odd. So it's going to have the same end behavior as negative x cubed. So that means as we are approaching positive infinity, my function is approaching negative infinity. Now, when we get to part C, we have a rational function, and the end behavior of a rational function is horizontal asymptotes. So there's a little shortcut we can use to help us find this. We look at the ratio of the highest degree of the numerator and denominator. So this is the limit as x approaches negative infinity of 3x squared over 4x to the fifth, which is the limit as x approaches negative infinity of 3 over 4x cubed. Now that's going to approach 3 over negative infinity, which is going to be 0. Now remember, the shortcut here for that is since the degree of the denominator was greater than the degree of the numerator, that end behavior will always be 0.